Okay, sorry for the delayed start. Setting up the printers took a little bit longer than I expected. But yeah, hello everyone. Welcome to week 5. You all made it. This is the last day of the class. Yes, it's a 5-week course. So yeah, this is the last day. Obviously, technically today is when I'm assigning your finals. So if you're wondering when your finals are due, people have been asking. It is a week from today. So turn it in like before midnight next week on Monday. Then we should be good to go. As you can see, I started grading stuff, so week 2 should be out later today. But yeah, if you're wondering where all your like assignments are going to, or like where you can see your scores, um, you should have to log in to like Google to submit your Google forms. So if you're wondering where your scores are, it should be sent to those emails. They won't be sent to your Purdue email, so check whatever email you use. Maybe it's like a junk email or something. But yeah, check that. You should get your scores. Everyone's doing pretty well so far, so you should be pretty good. Again, if you have questions about whatever score you got, maybe I like accidentally pressed like the X instead of the check mark and you got a 0 on something, please let me know. But I'm pretty sure I didn't. But yeah, if I did make a mistake or you think something's weird, just like ask me and I can probably correct it if I did make a mistake. So yeah, with that being said, I'm gonna do a lot of talking today, similar to last week, but then we'll also get into rendering, which is pretty fun. So yeah. Also, if you're here and like not remote today, we're doing a live demo. I have 2 printers this time because my friend has so graciously let me bring it, and he will come and probably show everyone how to use it. So yeah, we'll get to that in a little bit, but I'm just going to be rambling for a bit. Okay, so this is a little bit of a continuation from last week, mostly just talking about material properties, because material selection when you're designing 3D printed parts can become very important. So the great thing about FDM or like, you know, these filament-based 3D printers are that they benefit from the injection molding market, right? So injection molding has been along for a really long time, and because of that, there's a wide variety of materials that are available. And because of that, uh, those materials are starting to become available to 3D printers. So some of them are designed for 3D printers to be a little bit easier to print compared to like their injection molding counterparts. But you can go into like pretty advanced materials and get great mechanical properties. So I'm going to be talking about a couple of them today. Obviously, there's like hundreds or thousands of different materials you could choose from, but I'm just going to be highlighting a couple here. I might talk about a couple that that aren't on these slides, but these are just kind of for you to know, especially when you start making things. I'd say the most widespread material that people print with these days is called PLA or polylactic acid. The main reason why is it's really cheap and you can get it in a wide variety of colors, and it's also very easy to print. It doesn't take like a really crazy 3D printer to print PLA, so they're usually pretty flexible. Um, you can see here it prints at like about 180 to 230 degrees Celsius, depending on your printer and like what speeds you're running at. And the print bed temperature is quite low. It's like 20 to 70 C, but in some cases you can print with no, um, you know, without a heated bed, basically. 20 C is basically room temperature. So if you don't have a heated bed, which most people do these days, PLA is, pretty easy to print. It doesn't warp that much, which we talked about warping a little bit last week. When a material cools down, it'll shrink a little bit, and if it shrinks enough, it can like detach itself from the bed and stuff, which is not usually ideal. So PLA is very forgiving. That's why people like it. The couple cons is that it's a little bit brittle, but it also means it's very stiff, right? So depending on what you're going after, like certain materials properties might be, something to keep in mind. They say lack of mechanical properties. Yeah, it's pretty stiff, but because of its, low melting temperature and stuff like that, it tends to not hold up super well under like really rigorous environments. Like if it's outside a lot, it could like melt in the sun and stuff like that. But if it's inside and it's like something on your desk, PLA is, pretty great. It's not like if it's in a climate controlled environment, it's not too bad. But yeah. Also, it's technically biodegradable, but it has to be under very specific conditions to be biodegradable. So for me, I kind of think of it as not really biodegradable, but it technically is because it's corn based. But yeah. ABS is a material that was really popular and then it stopped being popular and now it's kind of coming up again. The main reason is because it was very hard to print. But back in the day, you basically could only choose between like PLA and ABS. But now with the wider range of materials, it made ABS less relevant, but people are starting to use it more. The main reason why people stopped using ABS is because it was very difficult to print. So unlike PLA, it used to warp a lot, especially if you didn't have like a heated bed or like the right setup. But with printers these days, a lot of them can print ABS. Like I print ABS on these things all the time. But yeah, for me, I like it because of its, high strength and durability properties compared to PLA, along with its high melting point. So the high melting point means that, if I leave it, inside my car on a hot day, it's not going to warp. I actually printed ABS parts for my car and I bolted it into the engine bay and it is fine. So it's pretty cool. Like you can do stuff like that with 3D printing. I, Obviously, I have some examples of 3D printing that's not car related today, but we can talk about that later. Um, Most of these are PTG. Some of them are ABS and ASA. I can talk about them later. But yeah, you can see the print bed temperature is usually pretty high as well, and that's mostly to prevent warping. If you keep it warm, then it doesn't like shrink and cool down. So once you finish printing, then it can cool down and then it won't like warp into itself, if that makes sense. So typically I print with a print bed temperature of like 105 Celsius, but your mileage may vary. But yeah, it's a great material in my opinion. I like it a lot. One of the main cons is that it like creates hazardous fumes whenever you print it. Just because like it's really smelly. So I don't know if you've ever like modified Nerf blasters at all, but those are all made of ABS. And if you ever try to like Dremel out the inside and like cut those plastic pieces, you'll get some smells. So those fumes probably aren't good for you. You shouldn't be breathing it in. So if you're printing ABS, you should probably be, in a nicely ventilated environment or someplace that has some kind of filtration system. But yeah, it's a great material. I like it. A material that's not on here but is very similar to ABS is something called ASA. And ASA exhibits very similar mechanical properties to ABS, but its one advantage is that it's UV resistant. So ABS isn't UV resistant. So if you leave, I don't know if you've left like plastic toys out when you were a kid in the sun, but over time they'll like yellow and then they'll get kind of brittle. And that's because they're not UV resistant. Lots of like toys and stuff like that, like Lego, for example, are all made of ABS. So, they'll exhibit similar properties to this. But yeah, ASA is pretty great. Some of this stuff is printed in ASA, so it's UV resistant, which is nice, and it's pretty close mechanically. But yeah. PTG is another pretty popular material these days. We're going to be printing in PTG today. It is odorless, which is nice. But I find that it's a pretty good balance between PLA and ABS in the sense that you get like most of the printability of PLA, but you do get a little bit more mechanical properties, mostly in the form of like higher temperature resistance. It's not quite as stiff as a PLA, but it is a little bit more impact resistant, right? It'll bend a little bit before it breaks. It won't like shatter in your hand, but it's a pretty great material. I used to print with it as my primary material before I switched to like ABS and ASA. And it's mostly because it's a lot easier to print. You can see these temperatures are a lot less demanding compared to ABS. and you don't typically need an enclosure. Oh yeah, I forgot. For ABS, you do usually want an enclosure to keep the ambient temperature warm so it doesn't warp. But yeah, these are open frame printers, so I primarily print PTG on them. But yeah, one of the cons for PTG you'll see here is that it's susceptible to moisture. So that basically means it'll absorb water, and when you print with wet PTG, it'll almost like those water molecules will boil out, and then it'll cause like print defects. So like your surface finish might suffer a little bit, it'll look a little bit rough, and the part may even be a little bit weaker. So if you are to print PTG in a like fairly humid environment, which I find Indiana to be sometimes, it is pretty recommended that you do have some kind of system that dries the filament. I didn't bring my dryer today, but yeah, they're susceptible to moisture, and you'll see that some of these other materials are also susceptible to moisture, some more than others. For PTG, you can sometimes dry it and then like leave it out for like maybe a week or two, and it's still probably okay. But some of these materials we'll be talking about later almost exclusively are printed out of like dry boxes or like some kind of drying like system. But yeah, PTG is pretty great. It's pretty strong. You'll see that like again, this stuff down here, a lot of it is in PTG, and it holds up to all the forces that we subject it to. So it's pretty cool. Yeah, PTG is nice. Yeah, it's pretty cool. TPU is a pretty unique material. I don't know if I have any TPU prints with me today, but it is almost like a rubbery material in the sense that it's flexible and you can print with it, which is really awesome. I printed gaskets and stuff out of TPU for certain projects. It can help with seals and stuff like that. But when you combine it with other materials, like if you print a PLA with, or some parts of your model in PLA and then another part in TPU, you can get one piece parts that are flexible in certain areas, right? So for like robotics applications, sometimes people make TPU joints instead of using like nuts and bolts, and it's pretty cool because you get, one part you just print, there's no assembly, and it just works. So TPU is pretty cool. You can make really squishy things. I print we I brought benchies last week. I think I brought them today too. But I printed like a TPU benchy, and like it was really squishy. And my roommate's strength test for my 3D prints is throw it on the ground as hard as you can. So I handed him the TPU benchy, and it just like bounced all over the walls, and he was really confused. It was really funny. But yeah, TPU is really cool. You typically have to print a little bit slower than other materials just because of how flexible it is. But depending on what you're going after, it could be a really nice material choice. You can also like control how flexible it is by like changing the number of perimeters and infill, right? So making a part more or less dense can make it more or less flexible. So like durability, it's kind of like you could subject a piece of TPU to an insane amount of abuse, right? You can beat it up like my roommate did. He like threw it on the ground and it didn't break, right? But it's not strong in the sense that it's not gonna or it's gonna yield a lot if you try to bend it, right? So like like obviously my phone is stronger than a piece of TPU, but if I were to try to bend my phone, it wouldn't bend, right? So it's like quite strong. But then like the TPU, I could like bend it in half and almost like tie it in knots like a rope, but it's very durable, right? If I threw my phone on the ground, it'd probably break. I'm not going to do that, obviously, but the TPU parts, they can take a lot of abuse. I don't know if okay, we don't have any, but sometimes we print like there's no TPU in there, Harry. Yeah. Um, Sometimes we print like pads out of TPU to kind of take like impacts um, on top of like more stiff and strong materials, if that makes sense. So this is like, I guess, something to keep in mind where you can kind of combine materials to get like certain properties that you're looking for in certain areas. Yeah, it's pretty cool. Most printers today can print it, but it used to be really hard to print for TPU. But yeah, you can actually print it surprisingly fast, I found. But yeah, it's pretty cool. Now we're getting into more, I would say, like quote unquote engineering grade materials. So nylon is a pretty great material. It's a lot stronger than most of the materials we were talking about before, especially when you combine it with something like carbon fiber or glass fiber. So a lot of people will combine like a nylon with some carbon fiber. You'll get some really rigid parts, and they're typically really strong. The main downside for stuff like this that we're going to be talking about is that it just gets harder and harder to print. So typically, like all the easy materials, they're easy to print, but they don't have the best mechanical properties. But as you get to more difficult materials, you'll usually get some benefit from, great mechanical properties. So it's very strong. It's typically more expensive than other materials. You can get PLA for, I don't know, as cheap as like 10, 15 bucks a spool. But a nylon would be like 30 or $40, right? So it is more expensive, but obviously you get more mechanical properties for the money that you're paying for. Like PTG is susceptible to moisture, so it'll absorb moisture a lot. It's a lot more than PTG, so I'd recommend you print from some kind of dry box or something if you are printing nylon. And obviously you can see these print temperatures are pretty high, but it's pretty great. You can see it's kind of stretching far out in this kind of square diagram. Um, yeah, okay, so polycarbonate is also a really difficult material to print typically. Um, it is very, very strong because people use polycarbonate to make bulletproof glass, if you didn't know. So you can basically print like a bulletproof glass strong like material if in your printer if it's set up correctly. You can see these nozzle temperatures are pretty high and demanding, but it is possible. I've done it before. It was like it worked out okay. I think it's because I didn't dry it enough. But it is an extremely strong part. Obviously, it's not as strong as bulletproof glass, partially because of those layer lines that I talked about last week. Those are all weak points for the material, but it's really strong. It's really great. Lots of polycarbonates on the market are like a blend, so it's not pure polycarbonate to make it easier to print. So it's not going to be as strong, but it makes it more printable. Pure polycarbonate is very difficult to print, so yeah, but it's pretty cool. Yeah, there's a bunch of other materials out there. Like for example, I've recently come across a material called PET carbon fiber. It's very similar to PTG, but the G in PTG is for glycol. So it's a variant of PTG to make it easier to print. I don't know. I'm not a chemistry major, so I don't really know like the big differences. But PET is a lot stronger, but it's a lot more difficult to print. So like PTG, I printed at like 240 degrees. For the PET I use, I print at like 320. But that paired with the carbon fiber makes it extremely strong. I think it's like a little bit more than 2 times stronger than ABS, and it's quite a bit stiffer too. Um, I don't know. I'm kind of nerding out because it's a really cool material that I just recently got into. But yeah, basically the point here is there's a bunch of different materials out there, and depending on what you're making, you might want to do research on what you want your part to be made of. Like in most cases, in other traditional manufacturing, you'll be thinking about like, if am I going to use aluminum or steel? But for 3D printing, you can do the same thing, but for different types of plastics. So yeah, keep that in mind when you're designing stuff, because these things can really change how your parts function. For example, I printed some PLA parts and I put it in something, and there was a big spring in it. And then, when I subjected it to a lot of like loads and cycles, the PLA part would just like explode. But then I printed the same part with basically the same settings, obviously changing like temperature and stuff in PTG, and it held up a lot longer. And that was because, it's a little bit more impact resistant. So, you know, keep that in mind. This is really like specific and nitty-gritty stuff, but I think it's pretty important for 3D printing in the future. There's a bunch of places that you can print at Purdue. I forget if these links still work or not. But there's like 3D printing clubs all over Purdue. There's a bunch of printing services. I'm sure you probably know someone with a 3D printer, and a lot of the times they're more than happy to print stuff for you. I'm also more than happy to print stuff. So if you need things printed, I print things for people all the time. It's a lot of fun. So yeah, here's some resources for you. Obviously, I'm a resource as well. But yeah. Okay. So with that out of the way, we're going to go to rendering. This is basically the last thing that you're really going to have to do for this class. And it's rendering final projects. So I'd hope that you have started already. If not, it's not a big deal. But basically how this works is we're going to do two different renderings. So you'll see when you submit the assignments, there's two like render submissions. One is the one that we're going to do right now that I'm calling render practice. So please don't render your final. If you finish your final, don't render it right now. Render something that we've done in this class and then submit it as the render practice. And then for your final, submit the final that you've created and then rendered, if that makes sense. Anyways, if you're curious as to what rendering is, oh yeah, final project. If you were here last week, I talked about it. If you're here this week, I'll talk about it again. Basically, you do have a final for this class. I hope you did know that. But the requirements for this final are pretty lenient. And the reason is because we want you to kind of explore your design process and see what you can make. So I'm not going to be super strict and you have to do like this, this, and this. It's just 5 design features. So it could be like an extrude, like a fillet, or like a revolve and stuff like that. If you do more than one of the same thing, it still counts as more than one. So if you do like 5 extrudes, it technically counts. But I encourage you to kind of challenge yourself because this is where you really learn stuff. In my opinion, like doing your own personal project is the best way to learn. So the final project is a great way to do that. So yeah, feel free to challenge yourself. Obviously, if you're short on time, you can probably bang something out pretty quick. But the last thing that needs to be kept in mind is that it's designed for manufacturability. Because I give you the option to 3D print your finals, I would really like them to be 3D printable. If you give me something that's like really small or has like really tiny features, it may not print very well. And if it does print and I hand it to you and it like breaks into a million pieces, we're probably both going to be sad. So I want, I want you all to have something and take away something from this class that you can like show off or like at least be proud of. Because if you make something really like small and like fragile, it might break, and I don't want that to happen. Like I guess I can roast like, some people. Um, these are some of the finals from last session. You can see like some of them are pretty like printable. This one is pretty good in the sense that this needed no supports. Uh, if you were here last week, we talked a lot about designing for 3D printing. So you can see like this sound one has these overhangs here that aren't 90 degrees, right? They look like 45, so it comes out and you don't have supports. And it's nice and printable. For designs like this, if it was to be printed like this, you need a lot of supports. So I printed it on the side. And then these slots here are like long bridges. So we talked about bridging last week. So if this is like a design requirement for you, like you can leave it in. But like in this case, we probably could have left it smooth and it would achieve the same result. Obviously, it's an aesthetic choice. But that's an example of a long bridge. For really complicated stuff, like someone made this lightsaber, it's kind of hard to have for design to be printed without support. For cases like this, I'll probably just be like, hey, like pretty awesome. Like, don't worry, it's not super designed for manufacturability, but we put in like a ton of work. So there is some leeway, but I do encourage you to printable. For example, this one, like this model is great, right? I like this, but you can see there's a bunch of supports on here, and it's really thin, to the point where I'm scared that if I remove these supports, it's going to break. So if you design something like this, keep in mind that there's a good chance that your product might break. The other thing, like as much as I love like this Pokeball and stuff, please don't send me spheres, because spheres have no like solid place to like place their part for printing, right? You can see like I piled on a bunch of supports underneath to get it to print, but like typically spheres aren't something that is recommended for you to print, just because there's literally like one single point of contact on the bed if you don't have supports.
Is there support? I
Yeah.
thought it was part of the design.
No, no. So it's pretty cool. These are organically generated supports. So like in the slicer, you can specify where you want the supports. Last week I think they were just like the standard supports, so they're just on lines. But there's another setting that you can change it to organic or like tree supports, and it'll grow like these things. It like saves a little bit of material, and sometimes it's like easier to remove, so that's why I do it. Um, but yeah, if you want to take a look at these, maybe just looking at them might give you a good idea of like what is a good idea to like design and what isn't. The other thing I'll talk about is like how thin things are. Like on this balcony looking piece, these pieces are a little bit thin. I mean, it kind of fine, but if it's something that might be more exposed or subject to like bumping or stuff like that, it might break. So for most features, I recommend you like keeping it like 2 millimeters or above. Obviously, if you're making like a cone or something, like the top of the cone is going to be smaller, but that's probably fine. But yeah, I did kind of just critique all of these. But overall, like these designs are great. But you might want to think about how these parts can be designed or optimized for the 3D printing shop.
Why is it necessary to bring the support all the way down here instead of just, like doing this like this?
Like it's growing out of the part.
Yeah.
That would typically just mean that you get bad surface quality because then you have to cut the support off and then there'll be like a little bit of stuff there where you support came out.
Why is this curvy line better than the straight line? Like if you see it's curvy, why is it better than just having a straight line?
What? Oh, this.
Yeah,
Why
why
is
is
it
it
more?
paint material?
Well, like if I was to print this with like normal supports, you probably wouldn't even be able to see the model. So it'd just be covered in like supports. So it saves like doesn't save that much, but like it's like you might save like a gram or two, just like that. But I find it easier to print, so that's fine. But yeah, sorry for the people in the last session who I just roasted, but I hope that these people can learn from like their design choices and maybe they can influence what you do. Hopefully. Cool. Okay. So back to rendering. Again, if you have questions about your final project, if you're like, oh, I don't know if this is printable, if you have it done now, you can like show it to me today, or you can just message me later. That's not a big deal. But yeah, please design for manufacturability. In terms of size, people have asked me size wise. I would prefer if it's like somewhat the size of someone's palm. But like some people print really tall things like rockets and stuff. So that's fine. Just keep in mind that my printer can only print like 250 millimeters tall. Well, actually, the printer that can print that tall is broken. So right now I can only print up to 220. But you know, my build plate on my big printer is 300 by 300 by 250. So if I can get that running, I'll be banging out a bunch of these finals on it. But please keep it reasonable because there's a lot of you and there's only like one of me. I do have like more than one printer, but if I'm gonna try to get all of these to you before you leave for summer. So if you can keep it reasonable and don't make something like ginormous, that would be preferred. Sometimes people send me things that are super like microscopic, like this big, and I'll scale it up. And sometimes people will send me things like 8 miles long, and I'll have to scale it down. So there will be there is a chance that some of your parts might be bigger or smaller than like in your Fusion design. Um, if the like dimensionality is important to you, like someone I think made like a toothbrush stand one year, and I accidentally printed it too small because I didn't know what it was, and their toothbrush didn't fit. Like please let me know if that's like important. If not, I might have to scale it to my discretion. So yeah, keep that in mind. Anyways, going back to rendering, we're going to be doing the last assignment. So we're basically going to take your model that we've created in this class and create a professional looking rendering. Obviously, you might be wondering why you want to render stuff, and it's mostly just because it creates a really high quality photo of whatever you've designed. You know, companies will do it all the time for commercials and stuff. Their models or the things you see on the screen aren't always like real. They'll like animate a rendering and make it spin around and stuff. So rendering is pretty cool. It makes your stuff look really professional, depending on how you do it. So we're just gonna do that today, and then you should be good to go. Okay. So I'm hoping you're all booting up Fusion if mine doesn't crash. Yeah. Did I leave the tools over there? Oh, did Fusion crash? Oh, that's awesome. Wow, Fusion crashed. Lovely. Oh yeah. Uh, the example on the slides is the Lego car, but you don't have to do the Lego car. You can do anything that you've done in this class. Um, I would recommend you apply appearances to it because that's partially what makes the rendering nice. Um, I hope this loads. Yeah, I mean it actually is hollow. It's a it's hollow. Mhm. So it's about 25% infill. So 75% of it is just air. No, it's not. Okay, sweet. He's connecting the Ethernet cable to it, which is hidden. So we have to like open it up. Okay. I'm just gonna pick the building blocks for this, but you can just do anything that we've done in class. Um, Again, I would recommend that you use something with appearances because that's what like that's a factor that like comes in when you're rendering stuff. I'm gonna hide the data panel. Okay. So when we've been in Fusion, we've almost always been in this design space where we've been, you know, making sketches and extrudes and stuff like that. But if you click this, you can see there's a bunch of other functions that you can do. You can do like generative design, which is pretty cool, where you can, you know, specify certain endpoints in like forces, and it can generate like a structure for you. And then you can do a bunch of other stuff like manufacturing, which is CAM. But we're going to be doing rendering today. So if you again, if you hover over rendering, you can kind of it gives you a preview of what you're doing. So I'm going to enter that, and it's going to load. Okay. So my environment is already kind of set up because I think I did it for this one already. But to be able to change things, you'll probably be greeted with like a plain gray background. So to change that, there's this button right here that says scene settings. It's right next to this like color wheel. If you click it, it'll kind of give you this pop-up on the side. It's typically, you should open it. It should say solid color under background. Um, you can change the brightness and stuff like that. I'm going to kind of leave it where it is. But if you change the background type from solid color to environment, it'll allow you to open up like Fusion's library of environments for you to apply it to. So I'm going to do that. And then for the environment library, I'm going to go over one tab, and then you can see there's a couple different options. Okay, yeah, mine are loading now. But there's a couple like light options, like cool light and grid light. For this assignment, I'm going to ask that you don't use these just because they all kind of look really similar. So I wouldn't know if you just didn't know how to use environments and you just like submitted it. So please choose a background that isn't like just the lighting. So in this case, like I'm choosing the plaza, but you know, you could do like the crossroads or dry lake or whatever. Please choose one of those just so I know that you know how to apply environments. Similar to like the appearances, you typically need to download them and then you can double click them to apply it. So, you know, let's say if I was in sharp highlights or whatever, and then I wanted to change to field, I could download it and then I can apply it. It might take a second. There we go. Okay, so, okay, raise your hand if you're having trouble with this. It is okay. Okay. So now that you have this background, hopefully. Oh wait, there's more people. Does anyone else need help with this? Okay, make sure under settings, the background type is changed from solid color to environment. Because if you don't do it, then you can click all you want and it's not going to do anything. Okay, is everyone good here? Okay, sweet. So if you haven't applied appearances already, you can do it in like the design tab, but you can also do it in here for the appearance library. So you click on the color wheel and then you can apply different appearances to your model. Obviously, I've done it here, but you know, it's very similar to how we did it before. I don't know, why don't I change one of them to be glass? But yeah, for your renderings, you almost always want to apply some kind of appearance or material to your part. Just because when it renders, it'll apply that material and it'll make it look a certain way. So like, I don't know, if I did glass to this, it might be a little bit clear. I don't know, we'll see how it renders. But yeah, make sure you apply your appearances, and then you can start rendering. There's a couple ways you can render. I'm just going to show you, like, we're going to start with doing kind of like a temporary local render, and then we're going to send this rendering out. So one of the advantages for using Fusion is that it is cloud-based, like I mentioned in like week 1. And this is one of the like cloud tools that you can use, in the sense that you can send your project or design to Fusion's servers, and then they can render it for you. Typically, rendering takes a good amount of time and computing power. So if you have a really crappy laptop like I do, renderings can take a really long time. I remember back in the day, I had a computer with like a Intel i5 and like 8 GB of RAM, and I tried to do a rendering. Um, I like started the rendering, I went and ate dinner, and I came back and it still wasn't done. So renderings can take a good amount of time, especially if you want a really high quality rendering. Um, so it's nice that you can just send your model out and then Fusion will render it for you. But yeah, we're gonna just start by doing like a temporary render to kind of make sure we know what we want, and then we'll send it out. Um, so there's an in canvas render button right here, and we're gonna select that. But then the final render is this teapot. But we'll do that in a bit. So if I click on the in canvas render, it'll start doing like a temporary render. So you'll see the screen will get like really blurry and really bad, but then it'll slowly like become nicer and nicer. Basically, how rendering works is it kind of like takes like a pixel and then it'll like subdivide that pixel and then it'll subdivide like those pixels until you get a really nice model. So typically, the longer you render something, the nicer it's going to be. But then, generally, there's a point where it just kind of looks the same. But yeah, I'm just going to start. You'll see it's going to get really blurry and then it's going to get nicer. So over time, you can see at the start, you could see those pixels really well. And then as it subdivides them more and more, the rendering gets a little bit clearer, which is what we want. You can see here on the corner, it kind of gives you like the elapsed time. So you see, like I've been rendering for about 30 seconds now, and like the longer and longer I render, you can see like it gives me like an estimated quality. So I'm like going more and more towards excellent. Um, if you want to change your orientation, if you move around, it'll get really blurry, and then you'll have to render it again. So uh, kind of moving it around and positioning it where you want can kind of help you finalize it if my computer doesn't crash. But you can see it's like extremely blurry, but then if I let go, it'll start to render again. Um, so yeah, so this is local right now, which is partially why it's slow. But the reason why I'm doing it like this is it'll kind of give me a nice idea of what the render will look like before I send it for the final render. So I moved it around a bit. Let's just say I'm happy with this orientation. Um, you can stop the in-canvas render by clicking the same button. And then you can go for your final render. So if you click on the teapot, it'll pop up with all these options. Again, one of the benefits of the education license is that we can get these final renderings. Okay. But yeah, if you don't have your education license working, you probably won't be able to do one of these cloud renders. So if you don't have it working, please like raise your hand. We can try to fix that. Um, but yeah, you can customize a bunch of these. You can change like the size and aspect ratio. I'm just gonna leave it how it is. Uh, in this case, we're sending it to the cloud, so we're doing a cloud render. And for the quality, we're doing it as final. So final just means that the rendering quality is going to be really high, and that's what we want, especially for your final projects. You can see here, like it says it'll take about 10, it's usually like 10 to 15 minutes for you to send the render and for it to come back. Um, so I'm just going to send it out. You can see we have like unlimited final renders, and it's because of the education license. So yeah, if you're having trouble with it, please let me know. But yeah, then you can just press render. It'll send it out, and then it'll kind of pop up in this like bar on the bottom. I already rendered it for last session, so you can see my old one right here. Um, but in the meantime, like this is submitted, and then we're just gonna have to wait a little bit.
Is it also rendering that on the computer?
No, so this is the cloud rendering now. So it sent it out to Autodesk servers, and then it'll take care of all of that for us.
How is it better to send it over to the servers
Again, the main benefit is because rendering takes a lot of computing power. And I mean, if you have like a really beefy laptop, like my friend Harry, he has a really great laptop, so he just renders everything locally. But you know, I'm just showing you that this is an option if your computer may not be as powerful. Because I know my computer, it's like okay, but if I wanted to render something, it takes like a good amount of time.
so how do I know how much time I'm going to take for my computer to run?
Well, sometimes it depends on the model too. But you know, like computers with like graphics cards, like dedicated graphics cards typically have like faster render times. Like how gaming needs like powerful GPUs, rendering is kind of similar. Um, I don't know if you've ever run any of like the GPU benchmark things, but like a lot of the times they will do like whole like rendering for like the GPU as a stress test. So um, if you open your task manager while you're rendering something, it'll be like maxing out everything. Like your CPU is going to be going crazy. And if you don't want your computer to sound like you're at an airport, you can just send it out. So that's typically what I do just because, you know, it's free and it's nice. But if you want to do it locally, you can. Um, if you don't have Wi-Fi or something, you can do that.
So I should, if I want to do it locally, then I would just wait until the time goes to excellent.
Well, the in-canvas render is kind of like a preview. So if you want to do a final render locally, you click the teapot like we did for the cloud render, but you can change it to local render. I'm not gonna do it because I don't want my computer to like blow up or something. But you can do that here, and you should have like unlimited just because you're doing it with your own processing power. Um, But yeah, I'd recommend you do the cloud render, but if you really want to do it locally and see what it's like, I mean that's perfectly fine too. Okay, yeah, that's fine. Once you get your render, to submit it, please download the rendering and send it to me. I'll get people like screenshotting like this, but it's not the actual rendering. They're just sending me a photo of Fusion showing the rendering. So please download it. So there's this download button here. Um, I don't know if your renders came in yet. I'm just opening my old one. But please download it and send me that image. Because people will send me like their in-canvas renders and stuff like that, but that doesn't show that you know how to do the final render. So please do that. Um, but yeah, rendering your final is the same thing, the same process, except you're going to be using your final project. There is extra credit if you want to import a background. I need to find the link, but there's certain places you can go on the internet to find like custom like environments or backgrounds for your final projects. So like I don't know, let's say you made like the Boilermaker special and you wanted it to be on train tracks or something, you could probably like find one online and then you can import that and then you'll get like 5 or 10 points extra credit. I think you can, but typically, like the environments for renderings are made with like really high quality cameras. Again, because when you render stuff, it's a really like high quality image. It's like typically more than like 4K. So if you don't have like an insane camera, um, like the background may look a little bit more blurry than your normal model, if that makes sense. But yeah, you can if you want. But typically, um,
Where should we save the render?
you can save it locally. Uh, like I just saved it to like my desktop or something. But as long as you have access to it and you can send me it for the assignment, then it's cool. But yeah, does anyone have any questions about rendering? Yeah, that's pretty good.
It doesn't look like it's working. It just looks like a blank picture.
I mean, it's a render is typically pretty high quality, so I mean, partially part of it could be like lighting and like material, like appearance things. Because if you have like certain appearances, it can kind of influence how the photo looks. Um, but it may not look exactly like something in real life. Partially just because of like how the appearances are applied. It just a rendering won't look like real life. It'll look pretty close, but not quite exact. Okay. Does anyone have any questions about this? Okay, sweet. Does anyone have any questions about the final? Because it is due next week. Also, please make it like school appropriate. I don't want to see like weird things. I really prefer not to. I haven't had that happen yet, but I just feel like I should specify that. We just should add something and then import it and see if it's reusable. Yeah, so you can design whatever you want. Again, you have. I know, go for it. So manufacturability is, if you were here last week, I talked a lot about like 3D printers limitations. So, making sure like you don't have extreme overhangs or really long bridges. Um, but basically, like how the printer works, it's like a hot glue gun, but it's super plastic and it's hot glue. So when it goes across, like it's really rich. And when it prints, it prints away. So when you get the result, there's nothing underneath for the material to rest on. So when you go across, if it's a force on there, the material is still soft, right? So it will sag as it goes across, and then the pipe will be like stuck. Um, I have a good amount of experience, so I'll probably orient it the way I see best. Yeah, I can change the orientation. So I think this I can typically tell like which direction something I prefer to submit one part. If you, I know someone one time like had a whole like chess set, yeah, it was pretty cool. But then I talked to them and then we printed like they made like a whole thing. Yeah, you can do that. I would just say make sure like the pedal on your flower and the stem are even. Someone from last session sent me a really pretty flower, but when I scaled it and I tried to print it, the petals were so thin that the printer didn't even recognize it. So I they gave me the part too big, so when I made it smaller, everything got thinner. And then when I pressed print, it generated the supports, but the model itself is so thin that it didn't do anything. So it just printed supports. Oh yes, that's a good point. So I'll teach you. So if you do want your final printed, which typically a lot of people do, you've been sending me screenshots for all your parts, which I do want, right? So there's a part where it'll ask you to like send your final. Don't send me the Fusion file. Just send me the screenshot of, your Fusion screen, which you've typically been doing. And then it'll like open to the next like area in the Google form, and it'll ask you like if you want your part to be 3D printed and for you to upload it. Um, the format that I would like all the finals to be in is something called a step file. You can also give me an STL file, but step is a little bit better. The difference between the step and the STL file is that the step file retains like all curves and geometry. So like if you like send me a step of this cylinder, I will get a cylinder. But if you send me an STL of the cylinder, what the STL does is it converts like your model into an approximation made of triangles, right? So it'll make like a bajillion triangles around like the circumference of like this like circle or this cylinder to create something that looks almost like a cylinder. Um, but typically you lose some resolution, right? It's not an exact curve, it's an estimate. So if I were to scale it up, you would probably see the triangles in the model, which I have experienced before. So to send me that, I'm pretty sure you go under export. There's this 3D print button, but just export it. Name it whatever you want. And then under type, you find step. I think it's a little bit farther down. Yeah, step. So right here, again, you can give me an STL, but it's whatever. If you ever go on the like 3D printing repositories, some people will upload their STLs and some people will upload their step files. Everyone like celebrates when people upload the step files because they're really easy to edit, right? Because all the model geometry is retained, like the cylinder will be a cylinder, right? So if I want to make this cylinder and I want to like edit something off of it, it's a lot easier to do it with a step file. Because if you try to edit an STL file, you're gonna be like, oh, like this triangle is like approximately on this face, and I'm gonna like add something to it, and it gets kind of annoying. Um, yeah, some people send or submit or some people upload STL files because they don't want people to edit because it's annoying. So, depending on what you're doing, like you could do that. But yeah, for this, I prefer step. But yeah, yes, we will. We have a good amount of time. But yeah, does anyone have any questions on exporting your files? You kind of yank them off. You just kind of pull them off. Typically, like I would use some pliers or stuff like that. Um, yeah. If you give me a model that requires supports, there's a likelihood that I will probably give you the part with the supports attached. Because sometimes I don't want to remove them, and then if I give you the part and you'll see how annoying it is to remove supports, then you'll understand why you design things without supports. But yeah. Any other questions? If not, we can go into the demo and more fun stuff. Are you good? Oh no. Okay. That is, then that would be very sad. Okay.